Hello everyone. I want to use our knowledge of how to calculate moles and the mole concept to now start applying it to different ways. And one of those ways is going to be for calculating what are called empirical formulas. So if you remember, an empirical formula is the lowest whole number ratio of any element. It's especially applicable to ionic compounds. So anytime we use our ion sheets, you will see that we are going to use the lowest whole number ratio of ions. Okay, so that is what's going to apply here. So it says the ratio of the number of moles of each of the element in a compound gives the subscripts in the compound's empirical formula. So there's a method of which we do this. Okay, so if you're given a problem, I don't know why that keeps happening, but if you're given a problem that looks like this, ascorbic acid, which is vitamin C, contains 40.92% carbon, 40.58% hydrogen, and 54.50% oxygen by mass. What is the empirical formula? So somebody went through and did this data. They did some type of analyzation of this, and they analyzed a sample, and they realized that ascorbic acid has these percentage of masses. Well, since those percentages add up to 100%, we're going to assume that we have 100% or 100 grams of our any sample. It doesn't matter what sample. We'll just say it's 100 grams. So we're just going to conveniently convert this through no conversion really to grams. So since I have 100% of whatever sample I have, doesn't matter what size it is, we'll just change it to grams. Okay? So 4.58 grams of hydrogen and 54.50 grams of oxygen. Now, as I mentioned in class, it's not fair to compare things on a mass-to-mass basis. Things don't combine on a massive basis. Big things don't combine with big things. Small things don't combine with small things. They combine on a 1-to-1 basis, or a 2-to-1, or 3-to-1, or 3-to-2, whatever. Okay, so they combine on a moles basis. So grams is not fair to use. We must first convert to a counting unit called moles. So let's do that. So let's go our dot lines on each one. And as we work through here, we're going to convert each one of these three to moles. So 12.0, when we look at the molar mass in the periodic table, is 12 grams of carbon to 1 mole of carbon. This is 1.00 grams of hydrogen to 1 mole of hydrogen. This is 16.0 grams of oxygen to 1 mole of oxygen. Okay? So that cancels all this out. And when we do our math, I need a calculator. When we do our math, it's 40.92 divided by 12 is equal to 3.41 moles of carbon. This is just the same number, 4.58 moles of hydrogen, and 54.50 divided by 16 gives us 3.41. Okay, now, what we need to do now is we need a ratio. And the way we find ratios is divide by numbers. And the way we divide, what we need to divide by is the lowest number represented. Well, 3.41 is the lowest number represented. As a matter of fact, it's represented twice. So divide everything by the lowest number, the lowest set of moles you see. Okay? So this comes out to be 1 mole of carbon. This is also 1 mole of oxygen. But now I got to do a little math here. 4.58 divided by 3.41 gives us 1.34. Okay, 1.34 moles of hydrogen. Okay, now we can write a formula based off of these numbers, but it's not going to be terribly accurate. So if we write a formula, the lowest whole number ratio, again, it's not the whole number, but let's just go with it for now. We have 1 mole of carbon. We have 1.34 moles of hydrogen, and 1 mole of oxygen. It doesn't really work because you can't have, so if I took these, you can have 1 1/3 moles of anything, but you can't reduce that down to single atoms. You can't have 1 1/3 atoms of hydrogen. So why don't we just multiply everything by 3? That way we get rid of that third. So if I do it with this, I got to do it with all 3. So now our formula is C3H9O3, and that's correct. That's the lowest whole number ratio we can get. Okay? I'm sorry, C3H4. Jeez, oh Pete, that was terrible. I wasn't thinking. C3H4O3. That's the lowest whole number ratio, excuse me. So now I'm not going to do another problem because they all work the same. The first thing you do is convert your mass to moles. The second thing you do is divide by the lowest set of moles. And the third thing you do is you write the formula based off of the lowest whole number ratio. In this case, I had to multiply everything by 3 to resolve that 1 1/3. Okay? If it was 1 1/4, you would you would multiply everything by 4. If it was 1 1/2, you would multiply everything by 2. Okay? So keep it simple. All right? Let me know if you have any questions.